Hi, yeah, in this video, I want to do a demonstration how to fit a nonlinear mixed effects model using R. First, let's load in necessary libraries, nlme and ggplot2. Step 1, generate longitudinal data with a nonlinear fixed effects. Okay, so set random seed. We want 50 subjects, 10 repeated measures, define the time points. And now the fixed effects function here, it is a nonlinear function. It's a sigmoid function with parameters A, B, and C. Okay. And then we generate the data, create an empty list, and then loop through 1 to number of subjects, generate random intercept, random slope, and then let's do longitudinal data, do call, refine a data list. Okay, and here's what the data look like. So get subject ID, the time, and then the dependent variable y. Okay, we can do some graphics to take a look at that, the spaghetti plot. And step 2, fit a nonlinear mixed effects model using nlme. Okay. So first, we usually, since the nonlinear fixed effects usually is complicated, so we kind of define a formula before we call nlme. So here we get nonlinear model, which is y tilde a over 1 plus exponential negative b times time, parentheses time minus c. Okay, so that will be our formula. And then we fit the nonlinear mixed model. We allow random intercepts and random slopes for the b parameter, which is interpreted as a rate of change in this example. So you can see the syntax here. NLME nonlinear model, that's the formula, data equal longitudinal data. Now we have specify fixed effects, which is AB plus C tilde 1. Okay, so this is the way to specify fixed effects for A, B, and C. And then we have random equal to list subject ID equal to PD diagonal A plus B plus C tilde 1. This is saying random intercept and slope for A, B, and C. And we need a starting value for A, B, and C, which is specified as A equal to 5, B equal to 0.5, and C equal to 2. Okay, so if we do that, it's very quickly it's fitted. And there's some alternative ways we can specify the random effects. So listed here. List random equal to list of subject ID equal to tilde 1 plus time. So this will be random intercept and slope for a linear time effect, or random equal to list of subject ID equal to PD diag B tilde 1, only the random slope for B. Okay, and if we print out the output, it looked like this. So has the formulas and level subject ID, structures diagonal, and then get standard errors, standard deviations. Then we have the fixed effects here, and we have the correlation between A, B, and C, and then get standardized residuals, etc. Okay, so for inferences on the fixed effects, we get the p-values from here. So in this case, all 3 parameters are highly significant. Okay. So if we want to extract the estimated fixed effects, you can use the fix EF function, and then just print them out. So this is the estimated values, and for random effects, use randef, and then this is the first few rows of that data matrix. Okay, And we can do some longitudinal visualization, the fitted value, create a data frame for predicted value using the fitted function, and then use the ggplot to plot it out, look like that. Okay. And we can also plot the average predicted trajectory. So the random effects is the subject-specific model. It gives one estimate trajectory to each individual. So GE is our population average model, so you only get group average estimates. But since we have individual trajectory, we can average them into average predicted trajectory, which we can do here using the aggregate function, and you the formulas fitted till the time, data with longitudinal data, then function equal to mean. So that's the average, and you can plot out. So this will look like that. Okay. So this is the estimate of the nonlinear fixed effect. Okay. This is a pretty simple and straightforward example of nonlinear mixed effects models. Just to show you how to use nlme to do that. And this is probably the only nonlinear mixed effects model example I'm going to show in this series of longitudinal data analysis using R. You're welcome to do further studies on nonlinear mixed effects models. Thank you.